Hi. So you are building an AI agent. It can search the web, read files, call APIs, run code. Pretty powerful. But here's something most people don't think about until something actually goes wrong. What will stop the agent from doing something it shouldn't? For example, what if the LLM hallucinates a tool name and calls something it was never supposed to call? What if it decides the fastest way to complete a task is to run a shell command? What if it starts to write to files you never gave access to? With most agent frameworks, the answer is nothing stops it. There is no layer that sits there and says, wait, you're not allowed to do that. The agent just does it because nothing stopped it. And the common fix people reach for is putting rules in the system prompt. Don't delete files, don't run shell commands. But that's like asking the LLM to police itself. And LLMs can be convinced, manipulated, or just confused into ignoring those instructions. Today, I'm going to show you a proper solution to this. It's called the Agent Governance Toolkit. It's open source, it's from Microsoft, and it works with whatever agent framework you're already using. I am Zeal, an open source contributor to this project, and today we are diving into the first pillar, which is the Agent OS and the policy engine, followed by the agent mesh and trust layer, after which I'll be talking about agent SRE and observability. Before I get into any code, let me show you the shape of this toolkit because it has three episodes, and today we are going to cover the first part of it, which is the agent OS and the policy engine. It says how the policies are defined, how evaluation works, how actions get blocked before they run. The second episode will cover the agent mesh, the identity, and the trust layer. It covers cryptographic agent identities, trust scoring, and how agents communicate securely with each other. The third episode will consist of agent SRE and observability. It will consist of chaos experiments, SLO monitoring, audit logging, reliability engineering for all your agents. Think of these three together like the infrastructure layer for your agents. The same way you won't run a web server without a firewall, load balancer, and monitoring, you shouldn't run agents without governance, identity, and reliability controls. Today is just the firewall, which is the agent OS, the policy engine. And the best analogy for it is kernel. Your operating system sits between your programs and the hardware, deciding what's allowed. Agent OS does the same thing. It sits between your LLM and the actual tools it wants to call, deciding what's permitted before anything runs. Okay, so what actually is a policy in this context? The idea is simple. A policy just answers one question. Should this agent be allowed to do this specific thing right now? Not what should it do, that's LLM's job. Not what did it do, that's logging. Just is this action permitted? Yes or no? So a policy might say this agent can call web search, it can call file read, but it cannot execute a shell command. It cannot write a file. And it's allowed a maximum of 4096 tokens per call. That is a complete policy. That's all it is. In this toolkit, you define that with something called as capability model. Think of it like a job description for your agent. You're writing down exactly what the agent is hired to do, and anything outside that job description is blocked by default. And if you look at the source code, which is in the folder, the capability model is intentionally kept stateless. That's a deliberate architecture decision. Stateless designs means horizontal scaling, containerized deployment, and auditability all come naturally. If you're contributing, that's a constraint worth understanding before you touch anything in the policy layer. And now, this is the key thing. This is not a hint to the LLM. It's not something like a system prompt saying, please don't do this. The capability model lives at the application layer. The LLM never even sees it. If the agent tries to call something that isn't allowed, the policy engine will intercept it and block it before any code runs. So the LLM doesn't get any vote here. Okay, so now you know what a policy is. Now let me show you what actually happens the moment your agent tries to take an action, because that's where things get interesting. Your agent is running, the LLM decides it wants to call a tool. Let's say it wants to execute a shell command. Normally, that call would go straight to your tool executor, but with the policy engine in place, it gets intercepted first. The policy engine gets three pieces of information: who is asking, what kind of action is this, and what tool name it's calling. It takes those three things and checks them against the capability model, which I just explained earlier. Is this tool in the allowed list or is it in the denied list? Does this agent have the permission for this action? And then it returns a decision object, which is two fields, true or false. And reason, it tells you exactly which rule fired when the answer is false. That whole process where the call comes in, policy gets checked, and decision comes back, everything happens in 0.012 milliseconds. That's how fast pure deterministic rule evaluation is when there is no LLM involved. No neural network, no probability, just rules. 72,000 checks per second on a single machine. Now, there's one more thing worth understanding before we get into any code. That is the scope of it. So, the policies in this toolkit operate at three levels: global rules that apply to every agent in your system, tenant level rules for multi tenant systems where different customers have different permissions, and agent specific rules that apply to just one agent. When rules at different levels conflict, there are four resolution strategies. Deny overrides if anything says no, it's no. Allow overrides if anything says yes, it's yes. Priority first match, whichever rules come first wins, and most specific wins, the most granular rule takes precedence. Most people start with deny overrides. If there is any ambiguity, block first. Safest default. Okay, now you understand this, what's happening. Let's get into the code. So you can clone the repository. I have already cloned it and I'm inside the folder and I'm just installing using a pip install. I'm on Windows here, so exact same command for Mac and Linux. So it's installing. So this is just the policy engine package. The toolkit is entirely modular. It has separate packages for the identity layer and the SRE. So for today, this is what we need. So as you can see, it has been successfully installed. Now let's get onto the code. Okay, so after installing the packages, I created a demo policy folder with a file in it. So I'm going to show a tiny policy demo. So the idea is simple. Before an agent uses a tool, we evaluate that request against the policy. So instead of hard coding deep into the agent, I'm defining a policy document here. So the first and second rule says that the web search is allowed, file reading is allowed, but the next two policy blocks tell that writing a file is not allowed and executing a shell command is not allowed. Now I create a policy evaluator with that policy, and every time the agent wants to call a tool, I evaluate the request first. So let's test the file. So as you can see, when the web search is called, true is appeared. So that means the tool is allowed by policy. But when the shell executing command is called, it appears false because shell execution is blocked and the engine gives a reason immediately that it is blocked. So this is why policy matters in production. It's not just allow or deny, it's explainable enforcement. But here's something useful if your company already has policies written in Reco. OP or Open Policy Agent is one of the standard ways organizations write authorization policy across infrastructure. The nice part here is that I don't need to rewrite those policies just because I'm governing agent. I can load the same Rego policy and evaluate agent actions against it. So here I'm creating a policy evaluator and I'm loading inline Rego. The policy says deny by default and allow web search or allow anything coming from an admin role. So now I evaluate request where the tool is web search and the role is analyst. So here we can see that although the role is not admin, this still returns true because the first allow rule is matched. And the reason field tells me the decision came out from the OPA backend. One more thing, and I genuinely think this is a really good feature in the whole toolkit, which is MCP, Model Context Protocol. It is becoming the standard way for agents to connect to external tools. Think of it like NPM but for agent capabilities. And like NPM, it has a trust problem. There are attacks specifically designed for MCP tools. One of them is tool poisoning, where a tool's description has hidden instructions embedded in it that redirects your agent behavior without you knowing. Other one is typo squatting. It's when someone publishes a package called web search with a typo, hoping you mistype it in your config. As MCP adoption grows, this attack surface grows with it. The toolkit has a scanner built in that checks your MCP tool definitions before your agents ever run them. It catches these attacks at the definition level before runtime. The same way you run npm audit before you deploy. You run this before your agent uses any MCP tools. So this directly addresses OWASP ASI 01, which is agent goal hacking, which is the number one risk on the OWASP agentic top 10. And most people building agents right now have never thought about this attack surface. So if you're building anything in production, this is generally worth knowing about. Speaking of OWASP, everything we just built maps directly to specific risks on the agentic top 10. That's the official security standard for AI agent systems. First is agent goal hacking, second is excessive capabilities, and fourth is uncontrolled code execution, which we just covered in this video. Quick recap of what we covered today. We started with the problem agents with no guardrails. Then we looked at what a policy actually is, a yes or no answer to is this action permitted. We walked through how evaluation works, intercepts, checks, and gives a decision and a reason. Then we wrote it in the code, evaluated, and we saw OPA and Rego support for teams that already have policy infrastructure. And then lastly, we looked at the MCP scanner for catching supply chain attacks before they reach your agents. Next video is going to be agent mesh, the trust layer. So it tells you how agents get cryptographic identities, how trust scoring works on a 0 to 1,000 scale, and what happens when one agent tries to impersonate other. Repo link is in the description. If you want to try this out, drop a comment. I would genuinely like to know what you're building. See you in the next one.